What does Galileo and Albert Einstein had to do with my CNC mill and what I've been doing for the last week and a half, getting it ready to start making chips? Frame of reference. Bad physics jokes aside, I spent the last week squaring and tramming my CNC mill. Now, squaring and tramming, squaring is a process of making sure that all of the motions are perpendicular to each other. X to Y, Y to Z, X to Z, that everything moves perpendicular to each other. Tramming is the process of making sure that the spindle is perpendicular to the plane of the X and Y motion. You have to get those things right if you want to make nice, square, or accurate parts. So that's what I've been doing for the last week and a half. It shouldn't take a week and a half, but this is a new machine to me, and this was a new process to me. So learning is learning. I'm just going to grab my GoPro, and I'm going to walk around this machine and what I had to do. That's specific to this machine. It's a Skyfire SVM-2. If you have a Skyfire SVM-2, this video is going to be step by step for you. If you don't have a Skyfire SVM-2, this video is going to be a good set of ideas for whatever your mill is. Likely the structure of your saddle, which is how your X and Y work, is the same on most mills or similar on most mills. Z, I can't say. I'm going to guess probably, again, similar. But it should give you some ideas and give you some steps to make sure that your mill is plumb, square, trammed, good to go. So let's do it. Alright, here we are at the Skyfire, and we're going to talk over tramming and squaring the machine. I actually had this all taken apart, and I messed up the footage, so you get the already put back together version of the story. I think I'll be able to cover it for you, but it's not as great as being able to see stuff. So, taking the machine apart is probably the first thing you're going to need to do. To do that, you're going to remove this. There are 4 screws along here. That'll allow you to slide it back. You might be able to get away with just sliding it back. If you actually have to remove it, there are 2 screws in here, and I don't know if I'm actually, you might be able to see them in there. Anyways, so that's going to remove this front plate. You're then going to remove, I hope this will take a picture video of it, you're going to remove this black plate right here. You're going to remove that on both sides. There's 2 screws holding it up. So all of those are 3mm. So you need 3mm for all these. These are 4 if you decide to remove those. Alright, once you removed those, you are ready to square your X to your Y. So what do I mean by squaring the X to the Y? What I mean is that the X motion, so as I go X plus, right, or X minus, as comparison to Y plus or Y minus, that those are all perpendicular. They're nice, clean perpendicular to each other. What you're going to want to do is, so first off you have to realize that what you're actually adjusting is the twist of this plate here, or more specifically the twist that this is riding on. So follow me here. Let's say this is your y-axis, so it's moving here, and this is your x-axis. All right, so your y-axis we can't change our y-axis. We can't adjust the base. Well, we're just going to say we can't for now. I'm sure there's some edge case where you could, but this is bolted down to the casting. This is not adjustable. This big block of steel here, you can see that's called the saddle. That is adjustable. And on the saddle are the linear guide rails for the x-axis. So the x-axis is on, so you can imagine that this block is the saddle, and it's riding on some linear rails this way. So what we can do is we can move this block. So if we twist this block, the x-axis now moves in a different angle from the z, or from the y-axis. So that's what we're doing. What we're doing is we're moving the saddle to square everything up. All right. So that being said, there are 3mm headed set screws under this black plate down here. This is the plate you're going to remove. There are 4 of them. What you're going to need to do to make it actually move anything is when you remove this front plate and when you remove these side plates, the back plate's going to become available. You can then loosen the linear guide or the linear blocks for your y-axis. Now your y-axis linear blocks are loosened. Don't loosen, just get them loose. You don't take the screws out, just loosen them a little bit. There's actually 16 screws holding it on. There's 2 blocks on there's 2 blocks on each side. So there's 1, 2, 3, 4 blocks, and each block has 4 screws in it. You're not going to be able to really get to the inside screws. I tried really, really hard. It's incredibly tight under here, so that don't even, just save yourself the pain. Loosen all the outside ones. It's probably going to be good enough. Now I will say this: you're going to be cranking down the bejesus on these screws to get these things to move. So if one slips, even once, if you don't get a good deep seat with your Allen key, don't crank. And if one starts to slip, back it out, go to Home Depot and buy a new one, or Lowe's, or whatever your preferred store is. They're M5.08 set screws. So you can find them. Both Lowe's and Home Depot in my neighborhood had them. They're not magical, but yeah, don't risk them going bad. So how does this work? Well, when I tighten the set screw, it pushes the block away. So when I tighten a set screw, it pushes the block. If I loosen a set screw, unless that set screw is under pressure, it's not really going to do anything. It's just going to create room to tighten a set screw. So if I want to twist the block in one direction, if I want to push the block in one direction, I need to loosen the set screws that will be impacted by that. So if I push it this way, I need to loosen the back set screw. I need to loosen the opposite side set screw. So diagonal. I need to basically loosen these. If I wanted to adjust this one, I would need to loosen those. That's going to allow this thing to move ever so slightly. And there's not a lot of movement here in the first place, but it's going to allow it to move a little bit. So what you're going to do, you've got all the parts off. The first thing is that you're going to get yourself a nice long square right angle. In my case, that was a granite precision square that was 16 long by 12, which was actually bigger than I needed. You really only need about 7 or 8 inches of play. 200 millimeters. If you can get 200 by 200, you're in good shape. But you want a good precision square. I don't know if a machinist square is precision enough, but that's what you got. Go for it. I would say that a 1, 2, 3 block is probably too small. If you have a 2, 4, 6 block, that's probably great. Really need to get one of those. Precision granite also works, but 2, 3, 4 block might be just fine because you can 2, 4, 6 block because you can go 4 and 6. So what you're gonna do is you're gonna square it you're gonna square first the pretend something is our, here we go. Here's the thing we're squaring. You're gonna square this on the x-axis. So you're gonna get this so that whenever you move x back and forth, you have a dial indicator on your spindle that stays as close to 0 as possible. It's going to vibrate depending on the quality of your surface and how rough or smooth it is, and the quality of your dial indicator. It's going to vibrate. You want it to not move from one edge to the other. You want the same number because your spindle. We look at it. Your spindle, it doesn't move, right? So this point doesn't move in space. All right. So then once you've done that, you're then going to move it. You're going to move it on the Y. You want it, how I did it was this corner here, and I'm exaggerating everything, right? But I did this corner here, and so I moved on the Y towards me, which is Y plus. Now, as it's moving, straight line. This is you're looking at it cattywampus, so think a straight line. So what happens is if there relieves pressure on your dial indicator, then the number gets smaller, and you're going this way. That actually means that it's torqued in the angle I'm showing you. And so what you would want to do is push this way, which means loosening your set screw over here, loosening the set screw in the back, tightening this set screw. And again, you're going to bear down and tighten that sucker a lot. And then you're going to come back and go ahead and snug up the rest of the set screws. Then you're going to snug up one of your linear rails, and you're going to test it. And then if it's good, you're gonna snug up another linear rail and you're gonna test it again. And if it's maybe a little bit off, maybe you went a little too far, you might be able to, without loosening this side, you might be able to just scrunch down the other side and get the very, very final tuning. But you're basically gonna play with the set screws with loosened linear blocks, lightly loosened. Don't take the screws out. Don't get just basically break the tension on the screw, maybe go a quarter turn past that, maybe not even a quarter turn. So that's going to get you square in your X and your Y. That's the first step. So right, you're moving that saddle by moving those set screws. And those set screws are underneath the black plates on either side. Some bigger machines, it will actually shim the gaps on all of the linear blocks after they do this. I did shim one of my gaps. I don't know if you actually need to do that, but I did. So in my case, it was actually torqued this way. So what I actually ended up doing was loosening this one, and I actually pushed the snot out of this back corner over here. And then I went ahead, and once I got it where I liked, I shimmed this close one here, tightened it back down to make sure it was square. And then I did this routine of tightening one block, running it to make sure it was still clean, and so on and so forth. That gets you your X and Y. That's off of this block here. Now, you've got your X and Y. That's great. You need to get your Z. And so your Z could potentially, your spindle could potentially be leaning back or leaning forward, or your spindle could be leaning left or leaning right. Let me rephrase that. The column could be leaning back or forward, left or right. If the spindle is leaning in those directions, that's tram. But if the column is leaning in those directions, that means the Z travel will be different. So what you do is to find out if your Y to Z is straight, is you take your nice precision item and you turn it upright, and then you sweep the front of it. That's going to compare Y to Z. And if your Y to Z is nice and clean, mine was perfectly clean, you're not going to do anything. You're great there. And then you're going to check your X to Z, and you're going to sweep one of these sides of your precision square, whatever it is. You're going to sweep this side or this side. And that is going to tell you whether or not your column has a lean left or right. So forward back is your Y to Z, and left to right is your X to Z. Now, if you have a problem X to Z or Y to Z, you have to loosen the column. So the column is held on by 3 bolts on either side. So make sure 1, 2, 3, same 3 bolts on either side. Now, in my case, there was actually a bunch of junk in here. I don't know, they were trying to make it pretty or something, and so there was essentially Bondo. I've since protected this. I went ahead and sprayed some clear coat protector on it, but I had to chip away a bunch of Bondo to get my column to move. Now, this, I'm going to say, don't do column adjustments alone. You could do your X and Y alone. I would not do the column adjustment alone. The column probably weighs 500 pounds. And how I did the column, my column had leaned this way. So we'll talk about how you detect the leaned this way. We'll talk about how you detect your lean in a second. But what I ended up doing was I would loosen everything. I would hold the column in a slight direction. We would shim the side, reset it. I would hold the column, and somebody, and my assistant, in this case my wife, tightened it down snug. To break the bolts, I needed a 2-foot cheater pipe on my ratchet to unseize them. And when I tightened it back down, I did the same thing. But we tested. There's no movement in the column between hand tight and cranking it down. The difference is cranking it down means it's really not going to go anywhere. If it's leaning one way or the other, you're going to shim the side it's leaning towards. So if it's leaning on this side, I'm going to shim this side. If it's leaning in this direction, I'm going to shim that side. And you're going to shim the column, one side or the other, until, because we're shimming the column left to right, until it goes up and down nice and perfectly smooth. Now, if your column is leaning forward or leaning back, that is to say that you're not getting a perfectly clean number when you go up and down, you're going to shim the front bolts or you're going to shim the back bolts with additional shimming to square that up. So, hope that makes sense there. Now, how do you know what's what? So, if you have to think of it as you're either cutting in or you're going away. So we're going to look at X. We're going to look at XZ for a second. So if I start at the top and I get a higher number when I go down, that would make me think that I'm this way. But we're not thinking of it from the reference. We're not thinking of it from the reference of the part. We're thinking of it from the reference of the spindle. So if I start here and I get a higher number when I go down here, that actually means that my spindle is cutting in to the part. It's moving into the part diagonally. So if it's moving into the part diagonally, that means that the column is leaning in that direction. Now, same thing if it's going away. Just imagine, instead of imagine the part orientation being wrong, imagine what the spindle motion is. So if I set my dial indicator here and as I sweep down my part, my number gets smaller. That means I'm going away from the part. I'm going away from the part. So if I'm going away from the part, I'm leaning this direction, and I would shim that side. So that tells you, how, and the same for your forward back. If I start here and as I sweep down, I get a smaller number. That means I'm leaning back. I'm sweeping away from the part. And we're measuring the front of the part. If, on the other hand, I sweep and I get a bigger number, that means I'm cutting into the part, which means I'm leaning forward. Hopefully that kind of makes sense. Once you do all that, your X, Y, and Z will be squared. That is to say, you can sweep in any direction with a dial indicator, and you're going to, on right angles, and you're going to get nice, clean numbers. So, let's talk about tram. Tram is where the bit is not square to the table. So you can imagine that if I'm not trammed, my bit, I might be traveling it perpendicular to the ground, but my actual bit would not be square. It could be square, not square this way, it could be not square this way, it could be leaned forward, it could be leaned backward. How you handle that? With this machine, you're gonna, these are 90-pounder, 400 Newton springs. You're not going to want to remove them both at the same time. You're only going to want to take them off for limited amounts of time. What I did is I actually used a toe strap and a ratcheting strap, and I Z'd all the way to the top. And I put a ratcheting strap on it, and I just ratcheted this thing a little bit, and I made sure this was exposed. I made sure this guy was exposed, so the strap is wrapped around here, comes down, and it's wrapped around here. I'm not going to promise that's the wisest way to do it. It's what I did. So you're going to do that. You're going to take a 12 millimeter socket, or not socket, crescent wrench, and you're going to back this guy off. If he's a little tight, then maybe play with your Z-axis a little bit to see if you can compress and get tension out of this. I mean, he's going to be tight, but you don't want him to be clearly under pressure, because you don't want it to spring open on you. And we're going to move this guy away, and then you're going to remove this plate, right? And you're going to remove this plate, put that spring back. And you're going to do the same thing over here if you have to. I actually did everything just on this plate. So for me, the only thing I had to adjust was my, I needed to adjust, I needed to turn it, but I didn't need to go fore aft. I only needed to go on my x-axis tram was off, my y-axis tram was fine. So what I ended up doing was tightening the snot out of these two, same kind of thing, 3 millimeter, they're 5 millimeter grub screws with a 3 millimeter head, same exact grub screw. So tighten the snot out of these, and I loosened these slightly. When I got what I liked, I tightened those a little bit, and then I put the plate back on. I never ran a test. Well, I ran one test without the spring on there, and it did in fact affect tram. So the spring does things. So I was actually taking off the spring, tightening those down, putting the spring back, taking it off, tightening it down. I wasn't putting the black bar back on every time. Once I had all my tram good, then I put those back on. So there you have it. Once you do that, I can't tell you how to tram. So I can tell you what you've just learned is how to tram this angle. I don't know how to tram this way. I did not have any issue this way. I only had an issue this way. So I got lucky in that regard, I guess. Everything else was out. This axis was out by many thousandths and is now within a quarter thousandth. My column was out by many thousandths and now within the quarter thousandths. And my tram was out by many thousandths and now is within a quarter thousandth. So I have everything kind of now within a quarter thousandth of an inch, which is awesome. So hopefully that was useful. and hopefully I'll be able to start making chips soon.